welcome everybody. We want to get started tonight by introducing the alarm team. So I'll get started and then Julie, you're on deck. So hello, my name is Stephanie Letourneau. I am the community science specialist at Alarm. I'm the one you've gotten many emails from, and this is the beginning of a beautiful relationship between us of me being able to assist you through your stream team volunteer experience. Julie, you'll be up, and then Grace, you are on deck.
Hi everyone, I'm Julie Bastine and I direct Dickinson College's Alliance for Aquatic Resource Monitoring, and just want to say thank you so much in advance for spending the time with us this evening and being a stream team volunteer. Pass it off to my colleague.
Hi, I'm Grace Messlimer. I'm a junior at Dickinson College studying political science and environmental studies, and I'm a summer watershed coordinator. And Kyra is up next.
Hi, I'm Kyra Lerner. I'm also a junior here at Dickinson College, another summer watershed coordinator, and I'm a computer science major here at the college.
Awesome. And so we would also like to hear about who you are. So in the chat, could you please introduce yourself with your name, what county you're from, and you can do a stream nearby or the stream that you know you're monitoring if you have your site already. And while everyone is going through and introducing themselves, we're going to run through really quick the contents of your binder. Julie and Grace, do you all have a binder over there? Perfect. I'm going to have you all hold up things as I call them out. So Julie's holding our stream team binder. When you first open the binder, you will find the monitoring manual. That is going to be what we were walking through today. Next behind the manual are a bunch of resources for you all, including our volunteer policy. This is a volunteer policy from the college, probably similar to what you've got for your master watershed stewards, but it's in there for you to reference and read to what you've agreed to. And then behind that, we've also got considerations for your monitoring site, which is something that we've talked about via email plenty, and also the monitoring calendar. And then behind all of that, we have the first time sampling and QC guide. We also have a video that outlines this, and you'll learn more about the QC or quality control later on in today's presentation. We've got forms for that in there, and then in the back of your binder, you'll have data sheets for Stream Team, and you're going to be using one tonight. So if you would like to grab one right now, that would be great. Awesome. Thank you so much, Julie. Awesome. We have a great turnout tonight, and we have people from many counties. So I'm going to go ahead and get the presentation up and started and go over what we're going to do tonight. All right. So welcome to the Stream Team workshop. We are excited to do this again tonight. We had our first workshop with this cohort last week. And so we're really excited to have you. During this onboarding time, we have about 27 volunteers coming on with us. And that includes folks from Lackawanna, Luzerne, Perry County, Dauphin, and Cumberland County. So wide variety. We're really excited to have you here with us tonight. As you see on our agenda, we just went through introductions and the binder review, and we're going to go through a short 30-minute presentation to review the Stream Team monitoring process, what kind of parameters you're going to be doing, and then an overview of the entire process and Stream Team itself. And then we're going to start our pre-stream section. So it's the first part in your monitoring manual. And then we're going to have a 5-minute break for you to be able to fulfill any human needs. And then we're going to begin going into our hands-on sampling and testing with each other. And during our time together, we're going to have some time for you to be able to ask questions during any gaps between our demonstrations, but you'll also be able to put questions in the chat at any time that you need. So many of you joined us for the information session, or you might have heard about us or gotten presentations from us in your mastered watershed stewarded classes. But we like to highlight that the Alliance for Aquatic Resource Monitoring is Dickinson College's Community Science Center. We are about 35 years old. We're having our anniversary this fall. We employ about 10 to 12 student watershed coordinators, and we have students with us this summer. And so you've met Grace and Kyra, and we're excited for them to work with you tonight and more this school year. And then we employ students in the school year. We're made up of full-time and part-time staff. We are supported financially 35% from the college, and the rest is from external grants. A little more about our students. Throughout your entire stream team experience, you're going to be interacting with our students. They're an integral part of our team, of the training experience, of your workshops, and doing some research in our office. As a co-curricular program at Dickinson, we try to engage our students and to provide them with skills being in a nonprofit setting and working with others and their research skills. So we're really excited for you to be able to work with them, get to know them some more, and hang out with them. So some things that we did an overview of in the information session, but we do want to highlight some expectations from both our end and for you all. So as a stream team volunteer, you'll notice that we've tried to put you in teams, emphasis on the stream team. And so we've tried to have roughly about 2 people per site. And if you don't have a partner, it's in a case where that was your choice, but you might be taking out a family member or a friend with you, or we ask that you have someone know where you are. And we hope that this is for fun and also for safety. You know, some people use their time together when monitoring to go get coffee, to go hiking. So we do the teams for many reasons. When you are testing, we do want you to be aware of the commitment of it might take a little bit longer for your first testing. And that time is about 2 to 4 hours, not including driving time. And so we do appreciate the time that you do give for this, but we want to make sure it's super clear that it might take a little bit of time in the beginning. Once you get the swing of things, though, you'll be able to have this process streamlined and it won't take you as long. We also really are hoping to do macroinvertebrate sampling with you all in the next year. We haven't been able to do very much in person. We don't really have the green light for that yet. So in the fall, we're hoping to be able to engage our current stream teams and within this 1 year, get you through some macroinvertebrate sampling and a workshop. Another important note is that we do need you to keep your data sheets. This is really important for us because it's under our federally approved quality assurance project plan that we do keep our data sheets for 7 years. And so one responsibility is for you all to put them in your binder, keep the hard copies, and then in 6 months, in addition to keeping those data sheets, we'll be going through a workshop where I will show you how to upload your data into the online database, the Chesapeake Data Explorer. We also ask that you use your manual every time that you go out into the field. It's awesome that if you're able to memorize everything, but it's imperative that you're able to read through what you're following and use the equipment according to the manual exactly. We're also if you have any issues with your equipment, please let us know and reference the manual. We're available for quality control checks, and that's something that Julie will go through later on in the presentation. And we also have a lot of opportunities where you can expect to be able to meet other volunteers from your county and overall. And we hope for you to be in communication with us and to have fun. And so some things you can expect from Alarm. I, Stephanie, am your constant resource. The whole Alarm team is, but the majority of my position is to be able to manage Stream Team and to be a resource for you. So I'm available on phone, email, and for video conference. You can expect about 3 communications per month. This includes a newsletter. We send out a newsletter twice a month, and this will contain information about upcoming events, monitoring dates, and imperative information. We also will be coordinating your quality control events. So this is going to be another communication you'll get from us. One thing that we are really happy to do is be able to manage the equipment loan and maintenance. So we are there for you if you do have any issues with your equipment, if the batteries are dead and you need new batteries, or if there's something else going on. We are here. We are a resource for you. And we are also a resource to be able to give you new standards if things expire, all sorts like that. And then throughout the years, we hope to engage you in educational events and workshops that are going to be interesting for you and to increase your knowledge and interest in Stream Team. And then we'll also be doing, as we mentioned, opportunities for you to interact with the Stream Team community as a whole. And so now I'm going to pass it to Julie, who's going to go into the Stream Team monitoring specifics and overview of the water quality parameters.
Awesome, awesome, awesome. Well, thank you, Stephanie, for getting that kicked off. So now it's getting into the nuts and bolts of what Stream Team involves and what you'll be doing on a monthly basis and some of the specifics of what will happen in your first year to 18 months. So tonight is our monthly monitoring training. So every month that you go out, you'll be collecting 4 wonderful stream baseline parameters: water temperature, conductivity, pH, nitrate nitrogen. And you'll also fill out a data sheet which captures some visual observations at your site. And as Stephanie said earlier, we really hope within the first year to 18 months that we get your macroinvertebrate workshop scheduled and implemented. And then after 18 months to 2 years, we go through a data interpretation workshop. We have started to go through that with the other stream teams in our stream team family. And we have had some really great conversations about trends and relationships between water quality, land use, and geology. And we're starting to consider some other parameters for folks to monitor at their sites. You can see here that these are some possibilities that we built into the program. And we are definitely going to be adding water clarity / transparency to some of those future sites. And then as Stephanie mentioned, our whole program is covered by a federally approved quality assurance project plan. And so we'll be throwing out little nuggets of information during our training and throughout our time together that helps to add quality assurance into the program. And that is in accordance with that document. Something else to point out as we move into our site parameters specifics is this program is funded by a number of different entities: the Pennsylvania Department of Environmental Protection, EPA through our Chesapeake Monitoring Cooperative, as well as the Campbell Foundation. And that's one of the reasons that is how we're able to provide these loans of equipment. And so I want to give a shout out and thank you to our partners for making that possible. So let's get into our water quality parameters. A solid parameter for baseline stream monitoring is water temperature. And temperature is measuring the amount of heat present. And it's this fantastic parameter that has a really strong relationship to how land is being used as well as the geology. So for those of you that have limestone streams, you might notice that your temperature might be a little bit cooler. We have a limestone limestone stream here near Alarm's offices, the Latort. And, you know, temperature is such a great parameter because it helps to inform many biological processes. So warm water, you can see an increase of algal and bacteria growth to a point. You also, cooler water holds more dissolved oxygen, which our biota can take advantage of. Temperature is also one of 2 parameters in the Stream Team program that has a state standard. Something that Grace has been working on this summer is looking at the Clean Water Act and how that translates to Pennsylvania. And so she could tell you all about this state standard. And so you can see here in the units of measurements here is in Fahrenheit, but you can see the different ranges of temperature that you expect to see within cold water streams that are designated as cold water streams, warm water, et cetera. So temperature, fantastic. And we'll be measuring that with our Lamont Tracer Pocket Tester. Speaking of that Lamont Tracer Pocket Tester, that is the instrument that you'll be using to get conductivity. So conductivity is the ability of water to pass an electrical current. So one of the things that you'll notice in your conductivity meter, when you take the cap off, there's 2 electrodes. And what it's literally doing is it's passing an electrical current between those electrodes. Anytime it hits interference, it increases the value. And things that impact conductivity largely are your inorganic dissolved solids. So we've already had some wonderful conversations with our Stream Team volunteers about road salt in the water time and seeing conductivity levels increasing. For folks that have that limestone geology, you might notice that you have an elevated conductivity there. For those of you who have acid mine drainage in your watersheds, you might also notice some elevated conductivity with those activated metals and other or inorganic compounds dissolved in the water. Conductivity is a fantastic bulk parameter. So it lets us know that something is going on, but we have to do further investigation to find out what it is. Something to note that we'll spend time on during the training is it does require a dual calibration, and you'll do that every time you go out monitoring. And the unit of measurement is microsiemens per centimeter, which gets at the voltage and interference that happens between those 2 electrodes. Another solid, fabulous parameter is nitrate nitrogen. So nitrate nitrogen is the most abundant inorganic form of nitrogen. And so when you think about the nitrogen cycle in waterways, we very quickly come to nitrate. So even when you're downstream of a sewage treatment plant that might have some ammonia, which is one of the first phases in our nitrogen cycle, it very rapidly converts to nitrate nitrogen. It is a wonderful nutrient for plant growth and organisms in your waterway. But as we know, high levels of any good thing can be problematic. And so the state, and when we're talking about Chesapeake Bay issues, nitrogen, phosphorus, and other things like that are really important to keep our eye on. We will be using the Lamont Nitrate Nitrogen kit to measure water for this parameter. And the cool thing about this is it is a zinc reduction technique, so we won't be using any hazardous waste. The technique, you can use cadmium or zinc, and so we're really happy to go with a kit that doesn't have hazardous waste. Something else to know, and we'll cover this later, to test for nitrate nitrogen, your water sample does need to be at room temperature. We'll talk a little bit more about that later. And we'll be doing a color comparison. So when you're looking at elemental compounds like nitrogen or chlorides or things like that, we often use principles of spectrophotometry, where you're looking at absorption of light through color and wavelength in that piece of equipment. And so what we've done with this kit, and not what we've done, but what the manufacturers have done, is they've equated different color changes to different values of nitrogen present in the water. So we're using a color comparison technique that is based on the chemical principles of spectrophotometry. And last but certainly not least, we can't have a monitoring program in Pennsylvania without talking about pH, especially with our history of acid deposition. We're still the state with the most acidic rainfall in the nation. And so pH is a really solid parameter for us there. And so pH looks at water acidity, and that really gets at the relationship of your hydrogen and hydroxide ions in the water. We see lots of different contributors to low pH, from acid deposition, acid mine drainage. Where you see more basic levels of pH is typically related to limestone geology, where we're dissolving that calcium carbonate. And again, this is our second, only two of four of our parameters have state standards for it, and pH is one of them. And that has a nice wide range. The state is looking for values in between 6 and 9. And we'll be using a color comparison technique for this as well. So Stephanie talked about quality assurance and quality control. We are big proponents of this, and we always like to joke at workshops that we should have like a counter for how often we say quality assurance, quality control, and whoever gets the right number gets a prize at the end. We really should bring that back. But we have built a lot of assurances into the program to make sure that we are using our equipment effectively and getting the best data possible. So one of the ways that we do this is we would have both internal and external versions of quality control. So the first time you go out monitoring and collecting data, you'll go through this process. So right now we have August scheduled as the time for you to go through quality control. And what you'll do is we do a duplicate sample process where you'll collect a water sample, and you will also collect a sample in a quality control bottle. You'll test the water in your water sample, and you'll record that on your data sheet. And then you'll put those data values into your quality control form. And then we'll arrange a pickup time to be able to grab those samples and those forms. And then we'll test that sample using not only the equipment in your stream team kit, but we'll also use some other benchtop probes and spectrophotometers that have increased sensitivity. So you'll go through that in the first month that you monitor, 6 months after that, and then annually after that. So speaking of quality control, I mentioned we have that external check, and then we also have our internal check. So there's a couple of things that we do that are in alignment with standard methods. There is a book, it's called Standard Methods for Chemical Monitoring, and holding times is a really crucial thing that's important when you're doing monthly monitoring. So first and foremost, with water temperature, you will be getting that value in your stream, or you'll be getting it stream adjacent. So that is a parameter that you have to test immediately, because as time passes, the temperature will change. So the idea with holding times is we're capturing the values within the time frame in which it maintains its value before it adapts. So pH you have to test within 24 hours. Conductivity and nitrate nitrogen, we're looking at 48 hours. And the important thing for those samples that do get tested later on is they have to be kept refrigerated or on ice or in a cooler, nice and cool, so that we're preventing those chemical processes from happening and altering your values. And last but certainly not least, we have our acceptable precision ranges. So we are strongly encourage the use of replicates. We've always been a proponent of replicates because that gives you an internal check to see whether or not you're using your equipment correctly. And so replicates help to catch those potential errors that might be happening. And your acceptable precision range is based off of the equipment sensitivity and what we would expect to see at certain values. So for water temperature, it's half a Celsius unit of measurement For pH, we're looking for ±1. Conductivity, we're looking at ±10 microsiemens per centimeter. And then nitrate nitrogen gets a little tricky because our kit has different ranges for nitrate nitrogen. So we have different acceptable precision ranges based on the ranges of the kit. And yeah, on the next slide, we have this wonderful document that can be found off of our website, and I'll add the link to that later on, which is our guide to equipment precision and recording data, and we have all sorts of different scenarios of how to make those decisions about replicates, and do you round up, do you round down, and things like that. So yeah, so I think that's all I've got, and I'll turn it back over to Stephanie.
Awesome. Thank you, Julie. Yeah, so we're now going to walk through an overview of the water quality monitoring process. So this slide is showing you kind of from that step back of what this is going to look like. So this is me the third weekend of every month. We count it by the Thursday. So the third Thursday of every month, the Thursday through Monday, is when you'll be doing the monitoring. This process includes prepping your equipment, calibrating your equipment. Then you'll go to the stream and measure your temperature, fill your sample bottle. After you collect your sample is when you go back and you do your chemical tests. We have a cleanup, and then later on you'll go through the data upload workshop, and for now you'll be keeping your data sheets. All right, so the pre-stream. So before you go out into the field, the first thing that's important is for you to record the time that you start monitoring. And so in our database, we do record your monitoring time, and so this will help you keep track. You're going to gather all your equipment, which should be in your bin. If you keep your hydrochloric acid somewhere else, though, you want to make sure you grab that. And we're going to calibrate the Lamont tracer pocket tester. That is what's on the picture on the left. You want to make sure you calibrate this, and we're going to go through this step by step. After you have your equipment ready, the time written down, the date written down, this is when you plan on going to the field. But before you go to the stream, to the field, you want to make sure that you're putting your safety first. So we do have you in teams, but if you're not with a team member, please make sure others know where you're going. If you are not feeling well, please do not monitor. Be aware of weather conditions, especially this is Pennsylvania in the winter. We do have ice or snow piles that might be blocking your stream. If there are high flow conditions after a heavy rain event, or if it rained a lot the night before, please do not monitor or go with caution. It's up to your discretion, but your safety does go first. These pictures on the left show ways that we don't want you to be collecting your sample or doing your sampling. So this is actually one of our students in the past, the top picture, doing sampling over a bridge like that, not very safe. And then the bottom picture, I believe is trout unlimited. But we do not expect you to climb out on branches in the middle of the stream to grab your sample. We did give you a sampling pole to be able to help with that, or we do suggest doing the bucket method, which we'll discuss later. Being sure you have public access. This is something we've talked about when we're considering your sites together. And please don't put yourself in a situation that could cause harm. So if you see poison ivy, please don't try to walk through it. As temperatures are getting warmer, there's ticks, so do a tick check, all things that you would do if you're going outside. And then when you are at the stream, it is safe. You're ready to get your sample at the stream. You're first going to look at your site, and you're going to take note of some visual characteristics. So what's the stream flow like? What's the water color? What is the description? What's the weather conditions? This is also where you are going to record your air temperature using that Lamont pocket tester. And then you are going to get the water temperature, and that is the in-stream parameter. And then you're going to collect your water sample. We are not showing this today, but we have a great video that will show you all the different things to go through when you are collecting your sample. But a few things I want to highlight is that if you are going to wade into the stream, it's important to enter downstream to avoid any sediment disturbance, so that it would all go behind you. We're going to make sure we rinse out the bottle and the cap of the sampling of the water sample bottle 3 times. That's a magic number. And pouring that water out downstream again, so we're not disturbing sediment. And if you're using a sample pool, making sure that it is attached. And like I said, we have a great video that shows this in action. And once you're done, you have your sample, you're going to test for the remaining parameters. So this is going to be pH, conductivity, and nitrate nitrogen. You can do this at home, or you can do this stream side. Some people like to maximize their outside time. So if you are somewhere where there is a flat surface, you'll find out tonight, but it is important to have a flat surface to do your sampling. Some people do like to do that. But one thing to note that we've said is nitrate nitrogen should be at room temperature. And once we are all done with our testing, we've got our values recorded, we do have a cleanup process. We're going to do a slight overview of that tonight, but again, there is an in-depth video. This includes rinsing with tap water, alkanox or phosphate-free soap, and rinsing with a diluted hydrochloric acid solution. This is important so we don't have any leftover reagents in our vials or on our equipment from the previous testing. So we make sure we're getting the credible data each time. And then the last process of your monitoring event will be that time in between of keeping track of your data sheets. As I mentioned at your check-in meeting at 6 months, we're going to be doing a training of how to upload your data to the Chesapeake Data Explorer. This was talked about during the information session. It's a regional database with volunteer monitoring data from partners all over the Bay watershed. So, looking at your time as a stream team volunteer, we just did an overview of what you would be going through during a monitoring event, and now we're taking a step back and looking at what your experience is going to be like upcoming. So we're currently at this first step of the training workshop and site selections. Most everyone's sites are finalized. If they are not, I'm working with you in the next few days to make sure we have those finalized, but I have to give you the green light. And next month, or this month, July, is when you're going to be practicing. So you might have gotten a stream team newsletter this morning, and it mentioned that we do have monitoring weekend this weekend. So in the next 2 or 3 weeks, this is your opportunity for you to practice monitoring before you go through your first quality control event in August. And so more details will come out about dropping off or picking up that quality control sample, and we'll have a check-in meeting to see how things are going and answer questions. You're going to be collecting your data monthly, and then we're going to have that follow-up meeting with the data upload training, and then we're also going to do a second quality control check. So in your first year, you go through these 2 checks, and then after that, it's yearly. We're hoping to get a macroinvertebrate workshop within this year. And then after a whole year of data collection has happened, we're going to review your data, have a data interpretation workshop, and reassess what parameters that you all are looking at and see what your data might indicate should be added and what's warranted. And so we do have a lot of resources available to help you stay connected throughout this entire time as a Stream Team volunteer. One thing I've talked about is the Google Drive. We call it the Stream Team Exchange. So you'll have access to the virtual monitoring manual, past workshop presentations. We do have files, folders for you to save your data sheets. So if you want to take a picture or scan them up. And we also have documents like the data reminders up there. We also have wonderful videos on our website and our YouTube under our video library, and they go through step by step of all of the different equipment and sample collections that you'll be doing and chemical tests. These are great and a great thing to do to test yourself before you go out this first time or for your quality control event. All right, and so we are done with the PowerPoint portion. I'm going to stop sharing my screen, and we are going to prepare to begin going through the manual.
Excellent. And before we hop into that, just want to pause and see if anyone has any questions about the content we covered. At this time, you can throw it into the chat, or you can unmute yourself and put it out there. Also gives a chance for Stephanie to grab the materials that she needs. Excellent. All right, well, not seeing any questions, and just a friendly reminder, if anything occurs to you that you'd like to follow up on, feel free to put it in the chat, but you can also unmute yourself as we're going through the manual and the different components. So if everyone could please get their Stream Team binder out, and go ahead and turn to your Stream Team Monitoring Methods Manual. That would be great. And I'd love for you all to please turn to page 6. And we're gonna start with our pre-stream portion. There's a couple of ways that we have organized the manual. And so one of the things you'll notice in every section is there'll be a quick overview of what you'll be doing. And we'll have the equipment you need to gather and so on and so forth. So everyone, with your binder out, please gather the following materials. We are going to grab a data sheet from our binder. So go ahead and pull that out and put it to the side. And then the next thing you're going to do is you're going to dig around in your binder and find your conductivity meter box. And once you have found that, please go ahead and take that meter out and put that off to the side. Second, we're going to find our conductivity standards. And while you're digging around, you might as well take a look for those vials. Now, Stephanie had those nice and easily and accessible. Y'all might need to dig around. It might be in that beautiful caddy, might be a fun color. Ours is yellow. Anyway, so grab your 2 conductivity standards. And while you're at it, find those little old vials. And one of the things you'll notice about the conductivity calibration vials is we have one noted specifically they're specifically designated for the different values and the calibration you'll do. So 84 and 1413 micro Siemens per centimeter. And we're just gonna pause there for a hot second, taking a look around the room, see how people are doing. I'm seeing a lot of like ducking into the bin, pulling things out. And there's 2 last things you need to gather here. One is your distilled water wash bottle. And the last is a waste container. And as Stephanie said before, this can be an old jar that you're using. You want to label it as waste. And if you're going to keep it with your kit, you don't want to use it for anything else. So have a waste container as well. All right, so when you have gathered all of your materials, please give me a thumbs up, or you can use the reactions. All right, we got some thumbs up. Dylan, we got that. All right, so Paul, Steve, and Ellen, if you wouldn't, thank you, Ellen. Steve, yep, we got Paul, and the last person is Steve.
Yeah, I'm good.
All right, hey, thank you. Okay, so now that we've done that, we get to move into the fun component, and that is calibrating our meter. So before we get started, the very first thing you're going to do in step 1 is record the monitoring start time on your data sheet. So I'm going to pass that off to Grace. It is currently 6:43 p.m. So let's go ahead and start that. She's gonna fill that out. And we do like to keep track of the hours that we spend monitoring. We have all these grants, and we like to count that as in-kind matches. So thank you for tracking your time as well. We've already gathered our supplies, so now we can get started with the process. So step 3 under start your data sheet and gather and prepare the equipment is remove the cap covering your electrodes. Now it's a little like of a misleading thing. You think you might have to like turn it and then pull it off, but it actually doesn't have the ribbing on it. So you can just give it a little wiggle and yank it off. All right, I'm seeing a few out. And while we're going here, so hey, Stephanie, can you turn your meter and let's check out those beautiful electrodes that are passing electrical currents between them. Look at them, they're beautiful, fantastic. All right, so now that we've done that, let's rinse the electrode with distilled water over the waste bucket and shake it dry. The other thing that you're going to be rinsing with distilled water are your calibration vials. So those teeny tiny beakers with 84 and 1413 on it, you're going to be rinsing those 3 times with distilled water. And Stephanie's already put this out there, but get used to our magical rule of 3. We like things done thrice. So whether it's a lot of rinsing, a lot of inverting of bottles, all sorts of things. If you're ever questioning yourself, do it 3 times. And that always takes a little minute. We hear from people that when they are doing their monitoring, that rinsing takes up the bulk of the time. Not really, but you do a good bit of rinsing. So that's a little bit of foreshadowing for the rest of your monitoring experience. I am filling time while I'm watching the screen and seeing lots of rinsing going on. And when you have finished rinsing out your vials and things like that, go ahead and give me a thumbs up. And I'd just like to point out, if everyone is seeing the spotlighted video with Stephanie, she's doing a really great conservation technique where she's putting just a little bit of distilled water into her calibration vial and she's rolling it. Yeah, nice technique there, and way to save the distilled water. All right, I'm starting to see some thumbs up and some okay symbols. Still got a little dot. Yep, all right. Stephen Paul, how we doing over there? Nice use of the reaction buttons. I love it. I love when we got the expanded ones, and so I can do things like put a heart out. Anyway, all right, so now that we've rinsed everything with distilled water, we are now going to turn the meter on using the on-off button. And the first thing we want to do is we want to confirm that we are in conductivity mode. So one of the things that always happens as you turn your meter on is it goes through this whole self-cal thing, and then it pulls up your screen. And so what Stephanie's going to demonstrate here is if it's not, Stephanie, you pushed the wrong button. Don't worry. Oh, you might need to turn off. We'll see. Oh, look at you cycling between the different modes. It is hard to do things blindly, but you're doing it great. So to cycle between the 3 modes of the meter, you're pressing and holding that mode button. And one of the things that you'll notice that's happening on the screen is we have a MUS and a CON for conductivity. ppm and TDS shows up at the bottom when it's in total dissolved solids. And then the last version is salinity, which is ppms with SAL at the end. And I'm going to tell you to stop when you get to conductivity. You're almost there, and stop. All right, so is everyone in conductivity mode? Ooh. Nice, good job. All right, so we're in conductivity mode. And then the next thing that we are going to do is we're going to start the calibration process. So we're now at the bottom of page 6 in step 2, calibrate the meter with 84 microsiemens per centimeter calibration solution. So let's grab that bottle of 84 conductivity solution, and we're going to, what are we going to do? We're going to invert it. And how many times are we going to do it? 3 times. This is a potassium chloride solution, so we always want to remix it before we do our calibration. And once you've inverted it 3 times, you're going to pour approximately 20 mils of the standard. Oh, that was a generous pour on the Stephanie Letourneau side of things. But again, oh, it's expired. Okay, it's all right. So you're looking at about 20 mils. And one of the things that, again, with like conserving your resources, we just need enough to cover those electrodes. So putting that out there. Once you've poured out the standard, please place the electrodes into the solution. And as a good practice, we always say keep the meter suspended in the solution versus resting it on the bottom. That's a good practice. If you're out in a stream, you obviously wouldn't want to like put your meter, if you had a really shallow stream, into the sediment. And what we're going to do first is we're going to allow our meter to stabilize. Now, if this is the first time you're using your conductivity meter, it might take a minute for your values to stabilize. And what do we mean by stabilized values? We're looking for minimal fluctuation, so wanting those values of conductivity to be within 1 or 2. Stephanie's using a really great technique here. She's stirring as she's doing it. We don't know if this actually makes it stabilize faster, but it gives you something to do while doing it, so you feel like you're multitasking. I don't know about you. I'm cracking myself up, but hopefully you're having a good time. So Stephanie, I believe your value has begun to stabilize. So if we look at the screen, and I am going to ask everyone to look up and watch Stephanie do this before you do it on your own. So as you can see, Stephanie's nice and conductivity value is stable at 87.6. And I'm going to read the whole directions and then I'll walk her through it. So you're going to press and hold the calibration button for approximately 2 seconds until cal appears on the bottom of the screen and 84 flashes. At this point, you release that button. And then she's going to turn that meter around. She's not going to, but you would turn it around. Make sure you're watching the screen and you're looking for SA and N to appear on the screen. And then you take it out of the solution and call it a beautiful 84 calibration. All right, Stephanie, you ready for this? Everyone watching? Okay, so first thing is she's gonna press and hold that cal button, and we're all gonna watch and tell her once it appears. Stephanie, release. 84 is flashing. SA, end, immediately. You can take it out. We've calibrated to 84 microsiemens per centimeter. Okay, so now you've seen Stephanie do it, and now it's your turn. Hopefully your values have stabilized. So again, you're going to press and hold that cal button for approximately 2 seconds. The second you see cal appear on the bottom of the screen and 84 begins to flash, release the button, and this calibration happens really quickly. So hopefully you're seeing an SA and an end, letting us know that you have successfully calibrated at the low range. So I'm going to ask for everyone to give me a nice little thumbs up. All right, Holly Smith checked in with the thumbs up. We got a check from Dylan and Sarah and Ruth. We got one from Steve, Ellen, Barbara, and Curtis, right? Okay, nice. All right, so we're going to look for that thumbs up. How's it going over there, Judy? Awesome. Okay, well, look at us. We have 84 calibrated the low range. That's fantastic. For those of you with shale or sandstone, you're going to have values in that low range, so it's important we calibrate to that. Okay, so now that we have successfully calibrated to the 84, we're going to rinse the electrode with distilled water over the waste container and shake dry. And since we've all successfully calibrated to 84, you can dump that 84 solution into your waste bucket and put that vial and your standard off to the side. And again, we're all going to become really intimately familiar with rinsing. It's beautiful. Okay, so we've successfully calibrated to the low range, and now we need to calibrate to the mid range, especially for folks with your limestone and or your acid mine drainage. This is where that second calibration is really going to be important. So once you're done with your 84, have that off to the side. Please bust out your 1413 calibration solution as well as your 1413 calibration vial. Beautiful. So again, I'll walk through this with Stephanie and then, well, actually we'll all do the first part. So what's the first thing we're gonna do? We're gonna invert our bottle 3 times, remixing that potassium chloride solution. Once you're done with that, you're gonna pour approximately 12 milliliters this time, Stephanie. Yes, perfect. I'm just joshing with you. Anyway, so we're pouring out that approximately 12 mils into the vial, just enough to cover those electrodes. And then the second you've got that in there, put that conductivity meter in there, start swirling around, and let your reading stabilize. You do need a little more, don't you? I know. See, that's what I get for like being like, oh, you poured out too much the first time, then you didn't pour out enough out this time. But you all will find that sweet spot with the calibration vial and making sure your electrodes are covered. Now, so we started with that low range. So right now your meter has to climb. It's got to climb all the way up to your 1413. And so it sometimes takes 1 to 2 minutes to do this. While we're allowing our meters to stabilize, I just want to do a little PSA awareness about this meter. This meter is fantastic. It's one of the most credible meters under $200, but there's one thing you should know about it. It does not like cold weather. So it likes to move very slow in the winter, which makes us really excited that we're onboarding y'all in the summer. But as those temperatures start to get colder, you'll notice that your meter will be a lot slower. The other thing is we should have our meters in Celsius, and when it is below 0 degrees Celsius, you'll notice that your temperature will disappear. So all sorts of fun things there with that, but long story short, we want you to prepare for a slow moving meter in those winter months. That's where coming back to a kitchen table or an indoor environment is great. Okay, so I've been rambling on here to help buy some time to allow Stephanie's meter to stabilize. And Stephanie, you're fluctuating between 1396 and 1397, so I think that that is stable enough. So we're going to go ahead and go through that calibration process again. So watching this here, the meter is stable. We're going to press and hold the cal button for approximately 2 seconds until cal appears on the bottom of the screen, and 1413 begins to flash. Look, yeah, you can release. Good job. And again, this is going to take a little bit longer. That 84 went to SA and end immediately, but you'll notice watching Stephanie here, it's taking a little time. It's going from that 1396 and realigning itself at 1413. So it's going to take a little hot second. Did we see SANN? We did. I missed it. I was rambling so much. I missed my cue. Okay, so good job. Stephanie, you have calibrated at both calibrations, and everyone else, it's time for you to move forward. I would sing a calibration song, but I don't have one quite in my mind right now. We did our low range calibration. And now we're moving on to the mid range. Yeah, way to go, Paul. We got our first thumbs up. We got Holly checking in, Judy, Sarah, Ruth, Ellen. All right, we got the Dylan et al. Family, Steve. How's it going, Barbara and Curtis? Oh my gosh, did this just happen? I'm so glad we're recording. Everyone did a successful 84 and 1413 calibration. Okay, so this is our 4th monthly online virtual workshop, and the first time that the meters worked for both calibrations on the first try. Oh my goodness. Y'all are fantastic. Good job. Oh my goodness. Oh my goodness. Yeah, we should probably cover how to troubleshoot just in case, but we need to finish our directions. Okay, well done, everyone. I'm so excited. So now that we've successfully calibrated the low and mid range, it is now time to rinse everything. So we're gonna rinse our meter with distilled water. We're also going to rinse our 14, 13, and 84 calibration vials with distilled water. And you're gonna put them all out. You're gonna shake them dry, put them off to the side, and your conductivity meter is gonna be very prominent tonight, so you're not putting that away. But the calibration standard in the vials you can put away. And once everyone has put away the standards and the calibration vials, we do want to walk you through some troubleshooting tips. I'm trying to think whose meter we should use. You're using yours to demonstrate conductivity, or you're reading Kyra's demonstrating. So let's demonstrate with that one. All right, we're gonna take over the spotlight. Oh, we're going rogue. So Stephanie, I'm thinking we should do it because that's the meter that will demonstrate conductivity. And we don't want to clear the calibration. All right, right? Okay. All right, so everyone, now that we've done all of our rinsing, we are going to turn in our manuals to page 20. Now, for those of you that did an in-person equipment pickup, you've already been walked through some of this troubleshooting, but we're going to cover this again. So on page 20, we have a couple of different troubleshooting tips, including how to switch your meter from Fahrenheit to Celsius, and also what to do if your calibration is not working. So I'm going to let Grace demonstrate this here. So one of the things we're going to do is you can remove the batteries, you can replace the batteries, but the first thing to try is actually resetting the meter. So you're not going to do this. We just want to demonstrate this because we don't want to clear your calibration. So what Grace is going to do is she's turned her meter off. And then we are going to simultaneously press on, off, cal, and mode all at the same time. That was a really great look. She first try, it got a DFLT, so it's going back to default. And one of the things that you'll notice in our meter is on your meters, you have a little L and an M circled, denoting that you have a saved calibration, and we just wiped ours clean. The other thing that will happen is it will go to salinity mode. So you do need to make sure you're in conductivity mode. For those of you who are like, I'm not going to remember that one, page 20 is there. And we also cover the reset process in full details in our conductivity meter video. So, all right. With that, but you don't need to reset right now. We can practice resetting at the end so that you have your saved calibrations. Okay, so it is my fantastic stream teamers. It is 7 p.m. We are through the pre-stream and the presentation, so this is a really great time to pause for a human needs break. So if you need a snack, need to refill those water bottles, what have you, we'll come back in 5 minutes. Now my clock says 7:01, so we'll get started at 7:06. If you want to mute your video, go for it, and then just turn your video back on when you're ready to go. All right, so let's take that quick break.
All right, we're ready to get started with our at stream portion. Take it away, Kyra and Grace.
Awesome. So we will now go over the at stream portion of the Stream Team manual. You can find this on page 8 of your Stream Team manual. What we will be going over here is gathering the equipment and supplies that you will need for the at stream monitoring section, filling out your data sheet at the stream, measuring the water temperature in the stream, and collecting a water sample for conductivity, pH, and nitrate nitrogen. We will want to grab the following equipment for the at stream section: your sample bottle, your Lamont tracer pocket tester, your distilled water wash bottle, your sample collection pole, or your sampling bucket and rope, depending on which collection method you will be using, your monitoring manual with your data sheet, your waders or closed-toe shoes that are suitable for entering a stream, a cooler with ice pack and freezer packs. And this is very important if you are not testing your sample for all parameters at the stream. Your water sample must be transported in a cooler to the post-stream testing location if that is the case. Finally, you will also want to bring your pen and your cell phone. First, we will go over making initial observations and then go over collecting your water sample. On the first page of the data sheet, you can record your sampling and site information. Afterwards, then you can make your general observations and record them below. Each time you visit your monitoring site, collect a water sample from the same location using each same collection method. Record on your data sheet if you ever change locations. Samples should be collected from the middle of the stream where the water is flowing steadily, and you should use a clean sample bottle. Make sure not to touch the inside of the bottle or cap with your hands. There are 3 methods you can use to collect a water sample. You can wade into the stream, use a sampling pole, or use a bucket. On the alarm websites, we have videos that walk you through the process of collecting a sample using each of these methods step by step. Today, we will go over some important steps and tips for each method. To collect a water sample, you want to tilt the mouth of your sample bottle downstream and lower it into the stream to collect the entire depth of the stream or water column. Try not to let the bottle touch the stream bed when you do this. If you are going to collect with a sampling pole, you will want to make sure your bottle is secured tightly to the pole, as Grace is demonstrating now. You never want to have to chase after equipment in the stream, so you always want to make sure that's on there nice and tight. Additionally, you can adjust your pole by twisting the blue knobs and extending or retracting the poles, as Grace is demonstrating. The final method is to use a sampling bucket. If you choose to sample from a bridge, there needs to be enough room on the shoulder of the road to stand and move safely without worrying about traffic. Also, be aware that a bucket full of water can be heavy and difficult to get to the top of a bridge. Additionally, buckets will float on the surface of water, so you may want to attach a weight to make it easier to fill. The bucket you choose must be dedicated to monitoring, and moreover, no cleaning equipment or chemicals should ever be introduced to your monitoring bucket. On page 9 of the manual, there are important safety tips that should always be taken into account before you head to your site, and you should always review them before monitoring. Now we are ready to turn to page 10 to go over taking the water temperature of the stream. The Lamont tracer pocket tester measures water temperature, and the temperature will be recorded in degrees Celsius. As mentioned, water temperature has a direct correlation with dissolved oxygen, and this is important to stream health. The first thing to note is that whenever possible, you should try and measure the water temperature in stream. However, if this is not possible, this is fine and you can measure it from your sample. You will just want to make sure to note that on your data sheet. Now you're ready to remove your electrode cap and turn the meter on, pressing the on-off button as we said earlier. This would also be an excellent time to check the bottom right corner on the meter and make sure that you are in degrees Celsius. Is anybody not in Celsius?
Grace is not. So this will be great for us to show you if you are
Perfect.
not.
All right, so we'll go over quickly turning it into degrees Celsius if anybody needs to go over that quickly. So similarly to resetting the meter, first we will turn off the meter. And once the meter is fully off, we will press both the on, off, and the cal button at the same time. The meter will flash back to life, and then you will be able to note in the bottom right corner that it is now in Celsius. Awesome. Perfect. saw a thumbs up.
Was everyone able to get theirs in Celsius? Seeing head nods, thumbs up. Awesome.
Excellent. Awesome. So once you are in degrees Celsius, you are ready to place the electrode in the stream, or in this case, the water sample, and allow the temperature reading to stabilize. The temperature reading is the smaller number at the bottom right of the screen. And there is a nice diagram on page 10 to show you exactly where this is on the screen of your meter. Remember that the larger number is the conductivity reading, and this will be measured during the post-stream section, so you do not need to worry about that now. Awesome. So Grace's measurement is looking pretty stable there. So with that, once you have your nice stable temperature reading, you are ready to record the measurement on your data sheet in degrees Celsius. And you will take that in the first replicate box that Grace is pointing at right now. So once you have that measurement recorded down, you are ready to remove the electrode from the stream. Yes, as Grace has there. You will wait 30 seconds, and once 30 seconds has passed, you would reinsert it into the water and let it stabilize again. While we're waiting for Grace's reading to stabilize, I will mention that the values of the two replicates must be within the acceptable precision range of 0.5 degrees Celsius. If the values are outside of this range, you will want to measure additional replicates until the values are within range. It's looking like Grace's is pretty stable there at 26.2. So we can write that down for the second temperature replicate in the second replicate box on the data sheet. Perfect. And those values are within range. So once you have two values that are within the acceptable range, you are ready to calculate your average and record this on the average box within the temperature section. Perfect. Awesome. Take note that Julie rounded up there. You may have, that is exactly how you want to calculate that when you have two values of that sort.
And also those reminders can be found in your data reminder manual.
Awesome. So once you have your average and your two replicates, if you are in the stream, you would exit the stream, and then you're good to turn your meter off and rinse the electrode with distilled water. As you can see, Grace is taking care to make sure that she gets both sides of the electrode well rinsed with distilled water. And once you are done, you can once again shake it dry. Awesome.
Big muscles.
Oh yeah. You're ready to replace the electrode cap. And with that, that concludes the at-stream portion of the monitoring process. And I will pass it over to Grace Mesmer to start the post-stream section.
Well, and as folks are finishing that, I did realize that I forgot to read one step in your conductivity calibration. So if everyone can look at your data sheet on the front, there's a spot there for you to check off that you've gathered your equipment. And there are also two spots below that that you can check off to note that you have calibrated at both the low range and the mid range calibration. And that is something that when we start entering data into the database, you'll be able to also add. And I did that on purpose so that our colleagues across the hall had a chance to get ready for their next part. And with that, I'll hand it over to Grace.
Thank you. So at this point in the monitoring process, you will have just finished your at-stream portion, and if you are not testing at stream side, transported your water sample back to your testing location in a cooler once again. And now we will get started with the post-stream tests. There are 3 tests: the conductivity, the pH, and the nitrate nitrogen test. So I will start by reading through the steps for the conductivity test as Kyra is acting it out. As Julie said before, conductivity is the ability for water to pass an electric current, and it's based on the amount of inorganic ions such as road salt or heavy metals. For the conductivity test, you will need your beaker of sample water, which if you don't have from the water temperature or the water temperature test already, you will invert your sample bottle 3 times, as Kyra is showing. And then you can fill the beaker up enough that the electrode is covered, just like you did for the calibration solution. You don't need it super full. And then you will also need your Lamont tracer pocket tester that you've been using, and a bottle of distilled water, as well as your liquid waste container. Okay, so the first step of the test is to remove the electrode cap and turn your meter back on and make sure it's in the correct setting. It should have the micro Siemens sign there. Okay, as Kairos does. And now the next step is to place the electrode in your beaker and allow the conductivity reading to stabilize. For this test, you'll be looking at the big number in the center of the screen instead of the bottom one. And this may take a moment to stabilize. And while I wait for that to stabilize for Kyra's meter, I will also share the acceptable range of the meter. If your number is above 200, it will be a whole number. And if it's below 200, there will be a decimal point to the nearest tenth. So be sure to look at your meter closely and make sure that there's not a glare or anything to make sure if there's a decimal point or not. Looks like Kyra's is still going up a little bit.
Hey, and Kyra, you have shaded your meter screen with your hand.
There you
Thank
go.
you. Perfect.
And as your reading stabilizes, if you want to share it with everybody, you can either put it in the chat or call it out.
Let's hear those conductivity values.
325 from Barbara.
What?
Wow, and 77.8 from Ellen, 288 from Sarah, 237 from Ruth, 368 from Holly. I think that's the highest one so far. Kyra and Stephanie, how's yours doing? Oh, we have
Dylan.
408 from Dylan and John, right? Yeah,
What
okay.
samples does everyone have? Oh my goodness.
Yeah, can everyone share where you grabbed your water sample? Is this well water? Is it from your creek or?
Tap water.
And feel free to
Mine's-
take it out too.
Mine's tap water, but ours is it's from public wells.
Gotcha. And we know you have geology or limestone geology, so
Yeah.
don't know that as well for everyone else.
183 from Paul.
And we have 81.2 from Judy. Awesome. So like already I'm like, woo, thinking of your geology. How fun.
Kyra and Stephanie, is yours stabilized? Yes. Yeah, I think. Yeah, okay. So once you have a stable reading, you can record this value on your data sheet. It'll be right below where the water temperature was, and you'll do this in replicate 1.
What is the value over there?
We can unmute you. Oh,
107.0.
Thank you.
all right. And once you have recorded that value, you can remove your electrode from the water. Just like the water temperature, you want to wait for 30 seconds before inserting it into the sample again. So we will reinsert now for the sake of time, but while you're actually testing, make sure you wait 30 seconds and wait for it to stabilize again. And the acceptable precision range for your 2 replicates is 10 microsiemens per centimeter. So if your second replicate is not within 10 of the first one, you will have to do additional replicates until you have 2 results within 10 of each other. And it looks like Kyra's is about stable at 107. Oh, it just went up as I was saying that. Still gone. Oh, can't tell. Looks like it's about stable at 107.6.
Oh, it went up. Just
Oh, it's
as
going
you
back up
said.
and down
Yeah.
as soon as I said it. 107.7. Oh, now it just went up again. We'll say 107.7. It looks like it's still fluctuating right between there and 107.8. So that is within 0.7 for ours. So our range is good. Paul has 185 for his second one. That's great. And as you get the second replicate, make sure you record that on the data sheet as well, where Kyra is pointing out now. And you can also do the average there and mark that on the average spot. Be sure to still follow the precision range for the average. So if your result is over 200, make sure you round the average to the nearest whole number. And if it's below 200, round it up to the nearest 10th. 234 from Ruth, and 78 from Ellen, and 368 again for Holly. So hers is
Holly, that's
right
nice
on
and
track.
precise.
324 for Barbara, and 81.8 for Judy.
Nice.
Kyra's average is 107.4.
That's what I put too. That's awesome. All right.
And 409 from Dylan.
Nice.
So everybody's within the range.
I think so.
I think so.
Hard to
All
do
right.
the quick subtraction.
So once you have the two averages, or the two replicates and your average, you can do the cleanup portion of this, which is on page 12. I forgot to say that at the beginning. All of this is on page 12 of the manual, but you will now turn the meter off, and you can rinse off your electrode with distilled water, just like you've done with all of your other tests so far with it, and shake it dry as Kyra is showing now.
Appreciate that Kyra is shaking the meter away from Stephanie. That's a nice partner consideration there. Well done.
Very considerate. And then once you do that, you can put the electrode cap back on your meter, and you will also want to pour out your sample water into the liquid waste container from the beaker, not from the bottle, as Kyra is showing, and refill that for the pH and nitrate nitrogen test, since we did just do a test in that beaker.
Nice inversion 3 times. Well done, Kyra.
All right. And with that, I will pass it off to Julie and Stephanie for the pH test.
All right, all right. I'm gonna look at everyone. Looks like we're still doing a little rinsing. It looks like some folks are done. Thank you. I just got handed a water sample. Wait.
I like this having a partner.
I know. We should always monitor and do everything in teams.
I see why it's Stream Team now.
And for the record, we don't go monitoring unless we're in a team as well. So.
All right. Well, is everyone ready to go to our next page? Page 13 of your manual. It is pH. You see some turning of the pages going on. Awesome. Think we're all here. All right. So next we are going to be doing the pH testing. The Lamont Precision pH Kit measures the amount of hydrogen and hydroxide ions, which make up water. pH measured on a scale from 0 to 14, with 0 being the most acidic, 7 being neutral, and 14 most basic. The difference in which one pH unit is a 10-fold increase in acidity. So we are going to gather all of our equipment and get ready for this testing. So in your kit, you should have a blue Lamont pH sampling kit. Yep. We're going to have that in front of us, not the nitrate one, the pH one. Great. And I want to make sure we also have our sample water, our beaker with our sample water that we just poured out. Make sure we have that handy. Great. And then we can open up our blue kit. And inside you should find 2 test tubes, each with caps. We want to find our wide range pH indicator. So it's in this little drop bottle. You will only have one bottle. You'll find the OctaSlide viewer. It is this black viewer that has an OctaSlide pH color bar. So you'll have two bars. One is the low range bar and one is the high range. Great. And then not in your blue kit, but in your larger stream team kit, you'll find a syringe. You might have to go digging for this one. And if it is in the packaging, we're going to take it out. Today is the moment. We're breaking it in. And you also want to make sure you have that waste bucket handy, because we are going to do our favorite thing, more rinsing. Does everyone have all of their equipment handy and ready? Great. I see head shakes or head nods, not shakes. That would be bad. Great. Awesome. So we are ready to get started. So before we do our testing, we do need to prepare our equipment with the rinsing, similar to when we calibrated our conductivity solution. So Julie's going to show you how to rinse the syringe. You can pick up about 5 milliliters of water, and then she's going to pull the syringe down. It might be a little sticky if it's a little new. And then she's going to, then she's going to use our similar method of putting it around in the syringe and deplunging it. And we can also rinse our test tubes at the same time. So we are going to put some water into our test tubes, similarly about 5 milliliters of water. And we're going to cap them and shake them. And we're going to rinse our syringe and both of our test tubes. Well, you only have to do one test tube unless there's two of you. So Barbara and Curtis, you all will use both test tubes. And Dylan and John, you all will use both test tubes. But if it's just you tonight, then you only have to use one test tube. And Julie's going to show you 2 test tubes to show you some trainer tips, but she's doing all this 3 times. That is the magic number. This is round 2. This is round 3. See how she pulls water all the way down, and then she's deplunging it. And then we're putting it in our test tubes, capping and shaking. If you notice, she pulled the plunger all the way down to that 30 milliliter line and then pushed it back up. We want to make sure we do that to cover the whole surface of the test or of the syringe.
I just want to point out that when you're doing your stream monitoring, you'll always do replicates. But for tonight, and especially for the nitrate tests, we're being resource prudent. So for those of you that do have your monitoring partner with you, go ahead and do 2 replicates, and then you can match each other. Everyone else, it's up to you as to whether or not you'd like to do the 2 replicates in practice, or if you want to, conserve your reagents. Either way is totally fine.
Is everyone done with rinsing? I see a little bit more going on, no problem. All right, it looks like we might be on our last round.
So in addition to stabilizing our conductivity readings and calibration songs, we also need a rinsing song. We have a workout video that covers rinsing and things like that, but we really need the rinsing song.
Like a sea shanty, Julie.
Yes, I love it. So anyone who's musical or wants to strum an instrument, how many times we gonna rinse? We're gonna rinse it 3 times. Syringe and test tubes, gotta get it all. Rinse it 3 times.
I'm really glad we're recording this.
I forgot about that. All right, I think we might be good.
I think we are ready. All right. So we're gonna prepare our test tubes for for the testing by using our syringe to fill them with 10 milliliters of sample water from the beaker. And this is a good time to watch Julie before you do this yourself. Julie has a very tough syringe, but she's gonna pull up more than 10 milliliters. And we're gonna show you, you're gonna have some air bubbles in here. You see those air bubbles down by her cone? Right, so we're gonna hold it vertically and we're going to tap it on a surface, very lightly on a surface or on the table to get these air bubbles to go out the top. Look at that, air bubbles are gone. And then Julie is going to deplunge her syringe very carefully. I suggest that you do that, like hold the waste bucket at an angle or have, yes, like that. She's going to deplunge it to the 10 milliliter line. And there's a picture on page 13 of what the syringe looks like at that 10 milliliter line. You want the top of that bottom part of the cone, top of the bottom. That didn't sound very, very descriptive whatsoever. You want that line of the cone to hit that 10 milliliter point. And as your syringes get older, you all have brand new syringes, so they should be top notch, working great. When they do get older, you know, some plastics and the rubber, they do become a little bit more difficult. And that is one of the many equipment materials that we can give you to replace. Look at that. Julie's got that bottom of the cone at the 10 milliliter mark. Awesome. And now Julie is going to put it in the test tube. And if you haven't started already, go ahead and start filling up your syringe, tapping your bubbles out, and then deplunging to that 10 milliliter mark. And Julie is doing it one more time. For anybody who wants to watch one more time while they're doing it, remember, get those air bubbles out. And if you accidentally deplunge too much, that's all right. Shoot that into your liquid waste container and grab more sample. Awesome. And we are filling our second test tube. Holly, I see we've got Ed in there helping out. All right, everyone, let me know when your test tubes are filled and you are ready for the next step. Great. Julie's ready.
It is helpful having a second pair of hands. I like this.
I like it too. All right. So once we have our vials or our test tubes filled up, we are now ready to begin the process for adding our wide range indicator. So very similarly to our conductivity bottles, our sample bottles, we're going to invert this test tube or this dropper 3 times. And notice how Julie isn't shaking it, just invert it 3 times. And this is to mix the solution. You can then remove the cap. And while holding the dropper vertically so that our drops are the same amount when they go in the test tube, you're going to squeeze out 10 drops. And one trainer tip that Julie is showing you is counting out loud. And if you have a partner, this is a great thing for your partner to help you with. And again, she's adding those 10 drops. Notice how each drop was the same size because we held it vertically. Once you have those 10 drops, you will cap it. And you will invert it to mix the solution into the water. I see some inverting, great. So Julie's doing something that is really one of my favorite trainer tips is holding both replicates in the same hand so they're getting the same amount of mixing. This is especially helpful when you're doing the nitrate testing next. And it's also a little bit of a time saver. But if you want to share the wealth of a workout, give it to your partner. So once we have it mixed up, we're then going to be using our OctaSlide viewer and our color bars. And as I mentioned before, you have 2 of them. So you have a low range, which will go from 0 to 6.5. We have a high range from 7 to 10.5. And for demonstration purposes, we have ours taped on white paper. But when you're doing this, you'll be putting your test tube inside of that OctaSlide viewer and holding it up in front of a white colored background, like your wall, in front of indirect sunlight so that you can really get a good color comparison. And we want this to be within 1 foot of that source. I'm a big fan of a window in that indirect light. And Julie's going to hold up her vial or her test tube, and she's going to compare the colors and see what matches.
Mine is in between 6.5 and 7.
Ooh, in between 6.5 and 7. So in that moment, you are able to record the in-between for your replicate. So that means Julie can record 6.75.
And that is something that the manufacturer recommends, is the ability to read an in-between value directly in between the 2 readable values.
And then if you're doing 2 replicates, you'll go ahead and look at your second replicate. So Julie's looking at our separate second replicate.
That one is 7.
That one is 7. All right.
So can I record an in-between value of 6.75 and 7?
No, we cannot. So one thing, once you have your 2 replicate values recorded, and this is something that's highlighted in the data reminders, is that we can only record values that you can get on the equipment. And Julie's showing you a great image that shows you the values that you are able to record here. So between 6.75 and 7, we cannot average those with our calculator like that. We have to round up to 7 because we can actually get that on the equipment. We can't get 6.83333.3 on the equipment. I don't know if that's actually what it is. It's not. It's like 6.883, but awesome. What values did everyone get?
And feel free to unmute yourself and throw it on out there. All right, Ellen got a 7. Sarah, ooh, Holly definitely limestone. Ooh, Judy 5.5.
Oh.
Where did you get that sample? Can you unmute and tell us?
Sadly, from my well.
Interesting.
Yeah, we were inundated with rain. I even can see that that it's been disturbed. I know.
That's the lowest value we've seen in training yet, but all right. All right, so we have 5.5 to 8.0. Nice.
Nice job. And if your two replicates didn't match, we would do a third replicate, and there's space for that on the data sheet. All right, so we're done with our pH testing. And when we're done, our cleanup step is to pour the water from our test tubes into our waste container. Brilliant. And after everyone's put their their test tubes in their waste container, this is my favorite moment for us all to take a deep breath in through your nose and exhale, because it's 7:45, folks. We're almost there. You're doing great. We appreciate you.
Also creates a great space for transition and us to switch our supplies.
It's all you, G.
Good to go. Should I wait a couple of seconds for
Yeah. All right. So we're gonna pass it off now to Grace and Kyra to do our next test, our final test, nitrate nitrogen.
Awesome, thank you, Stephanie. So we are ready to go ahead with the nitrate nitrogen test. And nitrogen is an essential plant nutrient and can be found in many fertilizers. But excess amounts of it can cause problems, such as reduced oxygen levels, overabundance of aquatic plants, and eutrophication. The Lamont Nitrate Nitrogen tablet kit measures the concentration of nitrate nitrogen dissolved in water. Nitrate nitrogen is measured in milligrams per liter. So the things that we will want to grab now to prep for this is first what Grace has there, our blue nitrate nitrogen kits, and this time we want the nitrate nitrogen one and not the pH one. So we will also want our beaker of sample water, our Lamont tracer pocket tester. We'll go ahead and open up our nitrate nitrogen test and make sure that our 2 test tubes and cap are there. Again, to reiterate, this would be a great time if you're by yourself to go ahead and do 1 replicate as practice here. Grace will do 2 to again reiterate some of our favorite trainer tips. And if you're with a partner, you each can have 1 as well. So once you have those set, you're going to want to grab your syringe. Awesome. In the kit, you will want to check for your nitrate number 1 tablets. Grace's are in little containers, but yours should be just sitting in the little front part there in the metal slips. And on the back, they will be labeled. Awesome. Yep, that's a perfect demonstration there from Grace for what that will look like. Once you have nitrate 1, then you can grab nitrate number 2, nitrate CTA, or nitrate number 2 CTA. All of these names on the back are more than fine. As long as it says one of those, you are good to go. Awesome. Once you have those, you want to go ahead and grab your timer, which will be in your general kit area. Your OctaSlide 2 viewer and your OctaSlide 2 bar. Awesome. And if you are testing outside, you will want to grab the protective sleeves that are in your kit. You will only need to use these if you do your post-stream testing outside, and I will mention when we get to that portion of the test when you should pull them out and use them. So with that, we are ready to get underway here. And we will start by rinsing our test tubes and caps with the sample water 3 times. A little bit of water goes a long way with this one. So this is another good time kind of reiterating what we did with pH, getting a little bit of sample water into our syringe, getting it into each one, and shaking it with the cap on. Additionally, for this one, if you want to use your beaker to pour it in, that is more than okay.
It's add a little drop and shake or roll.
Absolutely. Again, Grace will do that 3 times.
Rinse, 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 rinse your test tubes. There we go. I made a jingle.
Yeah,
It's so beautiful, Stephanie.
we need the jingle and we need the sea shanty.
And you'll notice that actually Grace is, well, raise it up. Grace is actually switching to using the beaker because it's a little easier to pour out and manage than the syringe. So feel free to do what is easiest here.
All right, how's everybody doing there? If you are done, could I get a quick thumbs up? Awesome, we're looking almost there. All right, that looks good. All right, so now we are ready to move forward and to prepare our water sample. So now we want to pull out our Lamont tracer pocket tester, and we will be doing this to measure the temperature of our water sample. For the nitrate nitrogen portion, our water sample must be at room temperature, which is 20 to 23 degrees Celsius. So we will go ahead and check that quick with the pocket tester.
Make sure
Yeah.
if you need to pour more in that you are
Yeah.
inverting.
Julie did a great job of showing that inversion there. That was awesome.
What temperature are we at, Grace?
Can't see
I know our screens are.
our screen. Wait, hold on.
At 25.7. We're in a very hot room.
Yeah, the air temperature over here is 85.
Yeah, when you're after you transfer your sample from a cooler, this will most likely really not happen to you. These samples have been sitting in warm rooms for a while, so like you're more likely to have a sample that is too cold than is too warm. And if your sample is too cold, some things you can do to warm it up is leave it out in a place for a little bit, or put your beaker of sample water in a bowl of warm water, or just hold it in your hands a little bit to get it warmed up. And if the temperature does go above the range, you'll want to fill the beaker again with the original sample water and try again. But for today's purposes, the practice, we'll move ahead with this. And once you have your temperature, you will want to go ahead and mark off right there under the nitrate nitrogen that your sample was room temperature. Awesome. So once you've got your temperature set and ready to go, you are ready to use the syringe to once again fill both test tubes, or in this case, if you're practicing with just one, your one test tube, with 5 milliliters of sample water, this time 5 and not 10. So to reiterate some syringe tips here, Grace is going to take some more water than she needs, more than 5 milliliters. She will lightly knock out the air bubbles, and then plunge out the rest of the air in there and get that bottom of the cone there, that line right there on the 5 milliliter mark. That looks awesome. So that's one there. And one more time for the win. Awesome. And that's number 2 there. All right, when everybody has their test tubes good to go, another thumbs up would be amazing. Awesome.
Definitely helps to have some paper towels handy, just in case you have some spills when deplunging your syringe.
It happens.
It does happen. Let's see, is
Okay, we got
everyone
one.
ready? We've got lots of thumbs up.
Yeah, seeing a lot of thumbs up.
We're gonna wait a little bit.
But it's not as bad as it could be. There was some spilling.
It happens. All right. I go.
Yep.
All right, so awesome. We are ready to go ahead and move forward. So once you have your 5 milliliters in both tubes, we are ready to add nitrate number 1 tablet to the test tube. Grace is going to demonstrate here a great way to get your tablet in. So go ahead and watch that before you do it, so that you don't have to touch and get any contaminants or anything on your hands on the pills that would go into your sample.
They're not hazardous per
No.
se, but we do have gloves for you to wear, but we don't want to contaminate your sample.
So as you can see there, Grace held the little pill pack over the water and pushed it in over so it fell in. So that's how you want to try and go ahead and do that. Awesome. So once everybody has both their pills in, another little thumbs up would be great. Awesome. Grace and Julie are ready to go.
Okay.
All right, I'm gonna go ahead and we'll wait before we go ahead and move on. So once you have both your test tubes, or your one in this case with your nitrate number 1, you're ready to shake the test tube until the tablet dissolves. And your sample will be a little bit murky looking. That's fine. We just want to make sure that there's no like powder resting at the bottom of your test tube. Grace here is demonstrating again that great tip of holding both of them in one hand and giving them a good shake so that they both get the same amount of consistent shaking. And this one is just until we dissolve. So let's see there.
And this is your warm up to the workout.
Oh yeah, you're not, the workout's coming. That's looking pretty good. So as you can see there, there's nothing resting at the bottom of Grace's test tubes there, which means she is good to go.
Does the number 2 pill usually take longer?
The number 2 pill we will be doing with a timer. It has to be shaken for a certain amount of time, so yes. All right, it's looking like we're almost.
Yeah, we're good.
Awesome. So now that we have our nitrate number 1 in our test tubes, we are ready to add our nitrate number 2 or nitrate CTA to our test tubes. We will want to use that same method of holding the pill over the test tube and pushing it in. Another note here that if you are testing outside, this would be the time that you put your test tube into that little UV slip for this next portion of the test, and I will tell you when that comes out. But you, again, to reiterate, that only needs to happen if you are doing this portion of the test outside. Awesome. So as you can see there, Grace has both of her nitrate number 2 or nitrate CTA ready to go in her test tubes. So once we have that good to go, we are ready to set our timer for 2 minutes. And we will want to try and shake consistently as we can for that 2-minute period of time. It is okay if you feel the need, like about a minute halfway through, if you want to switch arms, go ahead. It's a little bit of a workout.
And if your timer does not have batteries, that is all right. You can set a timer with your phone. that is our fault. We definitely forgot to give you all batteries. So you can blame me.
Phone timers work great in that scenario.
It's the thought that counts, right? But like Kyra said, you are going to be shaking the nitrate tube for 2 minutes.
Yep. This one's a little bit of a workout. Good arm workout for you there.
Grace just switched arms halfway through.
Another great trainer tip. All right, so a little preview to what's coming next as we're coming down to the last minute here. After this, we will be setting our timer for 5 minutes and waiting for the reaction to finish. If you were doing this outside, you would leave your test tubes in the UV slips to do this.
This is a really great time for the teammate to cheer on the other person. Grace started to slow down and I gave her a little cheer to get her pace back up. Good job, Grace. You're almost there.
Get into the final 15 there, Grace. You're doing awesome.
Yeah, keep it up. Do you need me to take over? That's also something you could do, so you could pass off to your colleague.
That's what the alarm workout video is for.
It is, it's true.
Practicing for this.
Build up your biceps and triceps through stream monitoring. The new way of getting in shape.
Awesome. So that is our 2-minute shaking period complete. And once your timer goes off, you will want to reset that timer for 5 minutes. Start that and set your samples down to be left alone for that 5-minute wait period while we wait for the reaction to finish. And in that time period, I will ask if anybody has any questions, comments, and/or concerns.
Looks like we've got people finishing their shaking and setting their timers. But we are here for the next 4-5 minutes together.
Holly, I noticed you unmuted. Did you have something you wanted to throw out
I
there?
did. Do we have, do you have a site ID? I'm looking at the data sheet. Do we have those?
Great question. Yeah, Stephanie, would you like to answer that or would you like me?
I can answer that. Yeah, so depending on what site we are selecting, whether it's a new site or a new site or a site that we've already had established, that site ID refers to the site ID that we're going to have in the Chesapeake Data Explorer. And that is the mileage of your site from where it meets the next water body. So for most of you, the Susquehanna, or if you're at a tributary until it meets the Cana de Gwinnett, Yellow Breeches, etc. And so we do this in GIS, a mapping software, and we have to get the mileage. And so if you do have a site, like for example, Holly, you're going to be taking over a Wirtz Run site that already has a site ID. But if we have some new sites, so I know a lot of our Dauphin County folks, and maybe some of our Cumberland folks, most of our Dauphin County folks, we're going to be doing new sites. And so that's something that we're going to have to go into GIS and create. So as of right now, make sure you write down your stream name in that area and maybe a description if you're at like a certain park. That would be great. But did I answer your question fully?
Yeah, we'll give you the site name and ID once we have all the lat longs and get the process. So yeah, and as Stephanie mentioned, the naming process, we use the United States Geological Survey nomenclature for site identification. So that's a pretty standard federal way of doing site naming. So, but we'll wait until we get our lat longs and you've identified that that's definitely where you're going to monitor, and then we can start building those site IDs for you. You'll definitely have it before you log data into the Data Explorer.
Yes, 6 months is plenty of time for me, I think. That was a good question. Any other questions? Comments, concerns?
I see Judy's doing a preliminary read. I love it. Nice light source you got in there, by the way.
Thank you.
Nice, nice, nice.
Okay.
I have a question. I just noticed that the sample bottle itself that you were using earlier had was like a wide mouth, and ours are narrow. Is that? Should we have the narrower one? Okay. Yes.
Yeah, so we're showing, so you should have, take note of which is labeled as quality control bottle, which is usually the narrow mouth, and then the sample bottle is a little bit wider.
Okay. No, they're the ones that the three that we have are exactly the same.
Smaller.
Oh, that's okay. All right.
If it doesn't make a difference.
It doesn't.
Okay.
And I think, I actually think it's easier to pour from a smaller mouth, so versus wide. So, yeah,
Just the collection itself will just take a little longer.
it will. Hopefully not too much longer, depending on the flow of your stream.
Okay, great. Thank you.
Click on the bottom left.
Okay.
Yeah, and the good thing about these particular, I don't need to fill time. We do use these particular bottles. They are chemical grade and meant to withstand the acid washing process. So if you should lose a bottle or a cap down the stream, which has happened many times, please let us know so we can replace it with the appropriate bottle.
Awesome. So once our timer goes ahead and goes off here, we are ready to go ahead and start measuring the nitrates in our sample bottles. So when the 5-minute timer goes up, you will insert your tube into your slide tube viewer. And if you are testing outside, this is the time that you would remove your test tubes from those UV slips. Again, Grace will be using this piece of paper here to kind of demonstrate color matching for this training, but you'll want to go ahead and put yours in the viewer. So to reiterate from pH, you'll want to hold it up against either like a white background or the natural light that Stephanie was talking about so that you can get a good color comparison.
So we got a little pinkness. What do you
There
think
you
is in between?
I think
What do we have over
Yeah,
there?
what do you guys got?
we have a 1.5 for the first replicate,
Awesome.
between the 1 and the 2.
Cool. And if everybody wants to either shout out or put in the chat what they're getting as well, that'd be awesome. I'm seeing a lot of zeros, a 1. Some more 1s, another 0.
This is good because for most of you, this is your drinking water. So this is
Yeah.
what we like to see.
True. When you have your first replicate, you can go ahead and record that in your data sheet as replicate 1, which you can see they've done there. And they've even moved ahead and gone ahead and recorded their second replicate as well. And really quickly here, as you all continue to measure the nitrate, I'm going to talk a little bit about the precision for this one. You must record an average value, again, that fits the equipment's precision capability. For example, you can't record a value of 3.5 milligrams per liter when reading the scale. In that case, it would have to be 2.0, 3.0, or 4.0 milligrams per liter. Therefore, if your replicate number 1 is a 2.0 and your replicate number 2 is a 3.0, you cannot record the average as 2.5, but must round it up to 3.0. You will do this for all your tests so that your average values will always be feasible.
Kyra, what's ours? We got a 1 and a 1.5.
Yes.
Can I put 1.25?
No, you cannot.
What? Why?
Because that is not within the equipment's feasible measurements. You will have to round up to that 1.5.
That was awesome.
So that's a good example of that little precision bit there. So additionally, again, another great place to check your data reminders. And for your acceptable precision ranges on page 15, or as Julie is showing there is the acceptable precision range for each of your nitrate values. The table is there. You can also see for the quits equipment as Julie is showing in the data reminders. If your values are ever outside of this range, you can run additional replicates until the two values are within the range. And when you have two replicate values within range, you're ready to go ahead and calculate that average like we did just there and record that final one on your average section of the data sheet. So if everybody's getting their second replicates as well, go ahead and throw your average either in the chat or shout it out and we can talk it out as well.
Holly, that's your well water?
That is our tap water from a well, a public well. It is pretty darn pink.
Well, something to keep in mind, Holly, even though there isn't a stream standard for nitrate nitrogen, there is a drinking water standard, and that is 10.
Oh.
So.
We have a filter on this, but it's not the filter out nitrates.
No.
Okay. So.
And when you go through QC, you'll get our spectrophotometer reading on it as well. So, oh, I guess you're not testing your well water.
I could probably send it through Penn State Extension. They could do it.
There you go.
What other, it looks like we have some low values around. So we got 0. Oh, Paul, what are you testing again? Oh no, that's pH. I'm sorry. I was reading your pH reading. I was like, oh my. Okay. All right, we've got 1s, we've got 0s. Oh, tap.
That's
Nice.
yeah. All right, these are looking good.
Nice.
Cool. Thank you all for sharing your replicates and your averages. So once you have that all set and you have that recorded on your data sheet, you're ready to pour the water from your test tubes into your liquid waste container, like so. And once you've done that, in the beginning as well, we used the pocket tester, so we have to go back to that and rinse that again, the electrodes of that with distilled water, as Grace is doing now. And go ahead and shake that dry once again. And once that is all shaken dry, ready to go ahead and replace that electrocap. Oh yes, and at this point too, you can pour your sample water from your beaker into your liquid waste container as well. And once you have your electrodes shaken dry and recapped, as so, that concludes the post-stream section of the monitoring process. You've made it through all the tests. Very well done. And with that, I'm going to go ahead and package it over to Grace to start going over our cleanup process.
Well, that concludes the post-stream testing.
Yes.
Thank you. I was trying to figure out how to spotlight us again. I would appreciate it.
So now that you have done all 3 tests, it is important to do your dishes as well. So that's the last thing we'll do during the monitoring process. Washing all of your equipment using our method that's on page 16 of the manual is really important because it is a quality control or quality assurance check to make sure that all of the equipment is clean and there are no contaminants for the next month so that your results won't be altered at all by that. So there are extensive YouTube videos as well not YouTube videos, our YouTube video has an extensive tutorial on the cleaning methods that we do ask that you watch before cleaning, but we will go through the general tips and equipment today as well. So to do your dishes, you will do all of these at a sink using a combination of tap water, Alkanox soap. Yours in your container will probably look more like your distilled water bottle. It has a similar spout to that, I think. And then you will also need hydrochloric acid and your distilled water bottle. And then you will also need gloves and safety glasses, which are in the kit, as well as the dish brush that we provided you in the kit. It's a smaller dish brush with like a wire handle, like Kyra's holding up. And some tips for the hydrochloric acid before we do start the dishes. We went over this at the distribution for your equipment, but make sure to not use hydrochloric acid in a stainless steel sink because it will stain your sink pink. So use it in a tub or a different sink or something that is not stainless steel. And also keep it out of reach of any children or pets and out of hot spaces like your car or your garage. Also, we once again do wear gloves while cleaning. The hydrochloric acid is not something that will harm you, so don't be afraid to use it, but it will cause some irritation on your skin, so you do want to wear gloves while you use it. And you also want to keep the tap water running while you use it because the fumes will stick in the air otherwise and they can make you nauseous. So if you keep the tap water running, that will go down the drain and not stick in your air. So we will use the following method for all of your equipment except for your calibration vials, which you used at the very beginning, the tiny little beakers, as well as the conductivity meter. Both of those you will only use distilled water on, so don't do this method with them. And the syringe, there is also a separate method for that is step 2 on page 16, and the method is in the YouTube video as well. But for the rest of your equipment, you'll use the following method. You'll start by rinsing all of the dishes with cold tap water, which Kyra is mimicking now. And then you will wash it with a small amount of the Alkanox soap. You don't need a lot, it will go a long way. And you'll use the dish brush to remove any particles and wash it like Kyra is once again doing. And once you do that, you will rinse it 3 times with cold tap water before using the hydrochloric acid. And once again, remember to wear gloves at this point if you weren't already. And you only want to use a small amount of the hydrochloric acid as well, and you want to make sure to cover the whole dish with it. Kyra is showing a good method to make sure that the entire dish is covered with it. And then you'll want to pour the hydrochloric acid down the sink while flushing with tap water still. And after that, you'll rinse your dish 3 times with distilled water. So you will go through this process with every dish aside from the ones that I mentioned earlier, and then you can set them out to dry before putting them back in your Stream Team kit for the next month. And you do want to keep everything together so that you don't lose any of it. So that is the dishwashing process. And once you finish that, you will also need to put the end time on your data sheet. There's a yellow box on the back of it, which Kyra is pointing out now, that has the end time as well as the total minutes you spent on it. So at this point, once you finish washing the dishes, you could put the end time on your data sheet. And then you want to put the data sheet away somewhere where you won't lose it. As we mentioned earlier, we do have to keep them for the quality assurance and quality control. And after 6 months of monitoring, you will also learn how to upload your data, but even after that point, we still want you to keep them. So please make sure to not lose your data sheets. But at that point, that is the end of your Stream Team monitoring and all of the post-stream cleanup things. So I think that is all we have for the monitoring process. And if anyone has any questions or comments or anything, now is a good time to ask them. Thank you.
Yay! So we do apologize that this training is resulting in dishes that you now need to wash before you go out sampling. And as Stephanie talked about earlier, this is, we're coming up into a monitoring weekend, which is noted by the third Thursday through Monday. So if you did want to get out and practice with your kits, feel free to do that before we do the official QC check in August. Any questions? Seeing some no's.
I just want to be perfectly clear. These do not get washed with acid,
Correct.
but it looks like the plunger
Yes.
and the,
Tubes, beakers,
got it. Okay, just want to make sure because,
and your sample bottle.
yeah,
So, yeah, so
got it.
at minimum, you'll have 4 test tubes, a beaker, a syringe,
Yep.
and a sample bottle. That will all get washed.
Good deal.
Judy, you'll have to test Gary to see if he remembers all this.
Looks like I'll be doing that this weekend.
There you go.
Nice. Awesome. Great question. Holly, I see you're unmuted.
You answered my question, thanks.
Any other thoughts, questions, concerns?
Manual is very detailed, so I think that's very helpful.
Awesome. Yeah, it's like a cookbook. So, I mean, some of us get to the point where we're memorizing the recipes, but we do ask that you use the directions and reference your manual every time you go out. You'll notice that even though we've done these tests hundreds of times, we were reading the manual and not doing it from memory. So, yeah, we do try to throw a lot of information in there. Excellent. Thanks, Ellen. With that, Stephanie, any other last wrap-up points or notable nuggets to share?
Yeah, well, if I have not confirmed your stream team site with you, I will be in touch in the next few days. I know, Ruth, I have not gotten back to you and Teresa yet. Tomorrow is the day.
We did
Yeah.
find all the sites though in Sherman's Creek, so that's good news.
Yes, found the site. So yes, if we have not confirmed, I will be confirming with you. And I'm available if you have any questions. I will be sending a follow-up email with the resources that we've mentioned today and a recording of the training. And yeah, if you did not get the newsletter this morning, please let me know. And also, if the email I'm corresponding with you is not your preferred email, please also let me know because that's the email I have on file. But yeah, those are my last notes. Thank you so much, everyone.
Yeah, this is great. One of our more efficient trainings, so thank you. I'm like, wow, it's only 8:20. Go.
Yeah, and I will also be sending out an evaluation of the workshop because we're always looking to improve, and I think we've gotten the virtual training down at this point, but we unfortunately, but we're always looking for your feedback, so you can look for that as well.
Yeah, and thank you all so much for spending the evening with us and participating in Stream Team. We're looking forward to staying connected in the coming weeks, months, and year, and also look forward to meeting you all in person soon.